Hey, what's up? What are you doing? What's going on? I wish I could show you. I have a notepad in front of me where I'm doing some work on a scratch paper. Darn it. But this is cool, okay? This is a coding challenge that was sent to me by an employer that I was pursuing, trying to get work. And this is not the actual challenge, it was in a code pen. But around 1:30 a.m. last night, CodePen was freaking out. I couldn't load the page, so I kind of got things into this little editor here, and I will show you the output of this code. And this is just one part of what the challenge was. Okay. Okay. Where did it go? Here it is. So they said we want you to create. They sent the code pen was it's just a web page with some HTML and some paragraphs and text, and it says, okay, we've got this button, and when you click the button the first time, we want it to display some information about yourself, and then the second time you press the button, we want it to display a GIF in the upper right corner. And then the third time you press the button, so I did the first two, I got those done, and now I'm on the third, is when you click on the button the third time, we want it to create a sphere. And then we want that sphere to be moving around and bouncing off the walls in a logical way. And then after that, when you hit the button again, we want it to create another sphere that is doing the same thing. And then every time after that, when you hit the button, it just increases the velocity of the spheres. And so I have this sphere now. Hopefully I didn't break it. I was adding new things. Let's see what happens. It's not a sphere, it's actually a circle. And so I'm a little freaked out. Like, do they want me to make a sphere? Like a real sphere? And do they want it bouncing around in like a three-dimensional space? Uh, you know, I don't know. I don't know what they want from me. But here's my ball. But the dumb thing about this stupid ball is it only travels at 45 degrees. And I'm like, this is no good. I can't submit this. I mean, it's not even a 3D ball. It's traveling in a 2D space. It's 2D ball. And let alone it's only traveling in one it's like a bishop in chess. It can only stay on the white squares or the dark squares. So I need to so I made some new variables. We've got the x and the y position of the sphere. Then we have a velocity, and then we have the bearing. I have not incorporated this into it yet, and it's probably going to be radians. So instead of that, I will say bearing is going to be like, oh, and radians start, like if this is the center point, the radians start here at 0, and they go all the way to pi, and then all the way to 2 pi. So it's backwards from bearing. If you're in a boat and this is north, the center's here, and this is north, and you're in a boat or an airplane or something, you're traveling north, that's 0 degrees. And you go a little bit to the left, and now you're traveling at your bearing is now like 360 or whatever. And then if you got 45-degree bearing, 90 degrees, and 135 degrees. So the ball was supposed to go this way. But so far, as I have it so far, this B does not, just close this. Yeah, so it just goes, it's got the set interval thing. So every 5 milliseconds, it will do this. ID. I don't know where this variable comes into play. ID. I just copied this off of w3schools.com, and then so if this is to make it bounce, if x happens to now be greater than the width of the inner width of the window, minus the diameter of the sphere, then we will, whatever the horizontal velocity was, we'll make it negative of what it was. And Vx, so right now is traveling 1 pixel to the right every 5 milliseconds. And it's traveling 1 pixel down every 5 milliseconds. And that's why it's 45 degrees of travel, and I think that's just so dumb. So we're going to say times math.pi, right? Math.pi. That's correct. Okay. Oh, pi is capital, it's case sensitive. I just want to thank you for being here. So I wanted to go, yeah, so if here's my center, this is 0 radians, 0.5 pi radians, 1 pi radians, 1.5 pi radians, and then so 1.75 pi is going to be the same as 135 degrees. Except if you were going from here, this would be 90, 180, 270, and then another 45, 310. But when you're on a boat or an airplane, 0 is here, 90, 180, 270. But this is not an airplane or a boat, this is a computer. Computers like radians, and therefore so do I. The Vx now is going to be a function of the bearing and the velocity. So I'm going to take B and V into my Vx. And so I just did the math on paper, and I had to refresh my circles thing here. So there you go, ta-da, a circle, a bigger circle, a slightly bigger circle, and so I had to say if x squared plus y squared equals radius, or in this case, radius is velocity. So we'll call it v, because we're talking about the distance that's going to be traveled by this sphere in this amount of time, 5 milliseconds. X squared plus y squared equals v. Okay. So I want to solve for one of the two. I want to find out, and then I'll say vx and vy, because that's the variables I use. I want to solve for vx first. So I'm going to say vx squared equals, and I'll just subtract vy squared from both sides. So I subtract it from the left side, now it's vx squared. And I'll subtract vy squared from v minus vy squared. And now I just take the square root of both sides, and that will be math, the syntax. Hang on. I wish there was a way to make this plain text by default, but I don't know. I'll zoom in a bit. Quite small we are. Math.sqrt math.sqrt, not Python. Javascript. There, squirt, math.squirt. That's fun. A times A, yeah, A squared plus B squared. Calculate the hypotenuse. That's what we're doing. We're calculating the hypotenuse. Except, no, we know the hypotenuse. The hypotenuse is V. And we are trying to find out the, well, we're going to be taking the sine and the cosine. So math, square root of Vx squared. Oh, I know what that is. It's just Vx. We've already solved for Vx. Equals math dot square root of V minus Vy squared. And this is, you know, it's not V times Y squared. It's Vy squared. But, you know, we all know this is JavaScript, so I don't need those parentheses. So, yeah, Vx. So I solve for Vx. I want the square root, except, wait, no, something's wrong. I need to use the sine and the cosine. So I've just assumed, in this stuff, I just assumed that, you know, I assumed that our bearing is 1.75 pi radians. Darn it. I'm confused. Just need to edit out this part because I'm going to have to think really hard and drink my coffee. I need to find the cosine. I solve for Vx. Vx is going to be the cosine. The sine. So the sine, the cosine of, for example, 45 degrees. Let's create a circle with a radius of 1 and zoom in. The cosine of, for example, 45 degrees, or 0.25 radians, or 1 over 4 radians, the cosine is the x-coordinate of this point, which is 0.695 approximately, although if I was at 45 degrees, then they would be equal. There we go. So the cosine of 45 degrees is the first number, 0.707. And then the sine of 45 degrees is equal to the cosine of 45 degrees, 0.707. So that's why when I'm dealing with this, and I'm assuming that, you know, we're traveling 45 degrees, I don't even need to take into account what my direction of travel is because they're both equal. So the cosine plus the sine will equal right. The cosine is the thing that gets squared. Because we're saying x squared plus y squared. So here, where were we? Right at that point where they're about equal, 0.7. 0.7 squared plus 0.7 squared is going to equal 1. Because so square this, and I'll go with the correct syntax, math dot cosine cosine of Vx. No. Vx is the cosine of b. The cosine of b squared plus math dot sine of b squared equals v, the distance traveled in 5 milliseconds. I believe this is correct. So I'll just go ahead and plug in this code and see, kind of just see what happens. B, and I think I want to like randomly generate B. So I will, oh, I'm sorry, times math.py, and I will put this in parentheses and go math dot random get random int. Oh, math dot random. Okay, that's the function they made. Yeah, it gives you a random number between 0 and 1. So I just need to put the parentheses here, and then I can multiply it by 2. So I get a random number between 0 and 2. And that's it. So then my sphere will start out traveling in a random direction, which is awesome. But then, so I can't just, I need to figure out my Vx, Vy. So, math, cosine, so this will equal a cosine, math dot cosine of b. It's going to be the cosine of b. Yeah! Times velocity. I need to multiply this by velocity. And that's where velocity will come into play. It's right here in deciding what my horizontal and vertical velocities are. They will be a function of my absolute velocity. And then maybe I can apply some gravity afterward, make it really interesting. Because, you know, I just need to fulfill the bare requirements, but it also has to be cool. It has to impress. So, oh, I don't need to square this. I don't need to square anything. They already squared it for me. When they figured out the cosine for me, when they wrote this function, the squaring has already been done. They already figured out. I didn't even need to look up all that x squared plus y squared nonsense. All I should have done just right from the beginning is skipped all that malarkey and just gone for math.cosine right off the bat. Idiot! You fool! Okay. Math.sine of b. Wow, that was so hard. Oh my gosh. We did it. Yes. Yes. It's done. We can ship it. We can ship it. Okay, let's go over the rest of this code. I don't know why this is called ID. Honestly, where does ID? There's, I don't even know how to use this program. ID, 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 ID. Yeah, so frame, okay, yeah. This is a function, so this variable equals this function, and by instantiating this variable and setting it equal to this function, I'm basically calling the function. Ah, boy. So it's going to do this function every 5 milliseconds. This function is if, as long as x is inside the window, or as long as x is within the leftmost boundary, you want it to stay within the right boundary, and x is the top right corner of the rounded square that is my sphere. And so I need the minus 50, because if I didn't have the minus 50, then the whole sphere would go just off of the screen before it bounced. But I don't need the minus 50 here, because the point we're talking about is this point in the upper left corner of the square that is rounded. Vx equals minus Vx. And Vx is math cosine of this random number, and we are all set up, and it's good to go. I can run it. Else if, yeah, so we're saying if it's great, if it's outside, then we're going to bounce the horizontally. Or, no, I don't need the else if, I need just a subsequent if. I need to just check for both conditions independently, because if I run this and it's traveling faster, you know, let me see if I can get this to glitch on me, because if it's traveling faster in the x axis and it bounces, if it bounces in one axis, it might forget to bounce in the other. Cool, we got a random direction. That's so awesome. Yes. Oh man. Yeah, it's a little bit slow, but you know it's slower because it's it used to be traveling 1 pixel every 5 milliseconds, but now it's traveling like uh, it's slower now that I can't explain, but it's slower because I'm going. Yeah. So before, the sphere would travel, it would travel 1 pixel to the right, and it would travel 1 pixel down every single 5 milliseconds. But now it's traveling less than 1 pixel to the right and less than 1 pixel down. The average of the x and y velocities is less than 1 now, because it's taking 1 and then it is, oh, where did I even put in v? I need to multiply it by v. Oops. This is good. So I'm convinced that if I leave it with the else if, because it's only going to do one of these, if it bounces on the x-axis and it happens to be traveling far faster, if it hits the corner, I just have to speed this up to see if I can lose any balls. I have to make mini balls, which might be difficult because I didn't just use JavaScript to append this div. I just hard-coded the div in there, gave it an ID, and then I called it with this variable. So anyway, once I've created the ball and set it in motion, now I need to increase the counter by 1, and then if the counter is, you know, if the counter equals 2, in the code pen they gave me, I have it using a switch case, but here I can just, I'll just say, outside of this if statement, I say, then if counter equals 2 or 1, then v plus equals 1. I'll say 0.2. Because if I say 1, then it'll only take 10 clicks to make that ball go as fast as it was just going, and that was like quite fast. If you want the ball to achieve escape velocity, I want you to work for it. So, and then we will say counter plus plus. We don't need to say counter plus plus because this is the last thing. In spawning a second ball, yeah, I should rewrite all this code so it spawns the div using JavaScript. But I was having trouble creating these CSS attributes with JavaScript. So, but I gotta do it because this is not playing around. We're not playing around. I think the ball's going faster. Hang on. It's not going any faster. If counter equals 1, my move. The button does my move. My move. Counter equals 0. If counter's less than 1, all this stuff is using let, so maybe I can only access these variables within this if statement. To test that, I will console.log x. Let's see if it knows what x is. I'm gonna bring my console over here. Okay. We've set the ball in motion. Now counter should equal 1. And it did nothing. It did nothing. I call the function if x is less than 1. Well, it's not. X is equal to 1. Because I already clicked once. So we don't do this. We go on. We move on. And then it says if counter equals 1. Just say something. Can we just say something to me? Let me know you're alive. You're not alive. You're dead. You're dead to me. Stupid code. Stupid code. Console.log. It's why isn't it doing it? Why aren't you doing what I told you to do? deeply equals. This makes me angry. Sheet math dot random math dot cosine. Do the function. I don't understand. Did I make a mistake somewhere? Yes. Here's my mistake. This if statement is inside of this if statement. And so it's saying if counter is less than 1, do all this stuff. Oh, by the way, if counter equals 1, then do this stuff. Well, of course counter doesn't equal 1 because... Oh, no, it does equal 1. Why am I not getting... I should still get the console log, but... Let me just fix it anyway. Yeah. Something's wrong with my indentation. Do I have an extra curly brace? I do. Wait. That's extra. So that contains my function. And then there's 2 entirely separate if statements within the myMove function. This should be good. Should good be. Oh man, counter. If counter is less than 1, which it is, then do all this stuff. Everything here. Oh, I see what's going on. This function is running every 5 milliseconds. This function is running every 5 milliseconds. This function calls this function. And so down here, if I say that V is now something different, this function doesn't even deal with V. There's no V in here. So V is used to calculate Vx and Vy, but I need to like what happens if I do this? I'm still not getting a console log. Makes no sense. This doesn't make any sense. JavaScript is dumb. Let's get rid of the counter thing altogether. And we'll just say I need to turn off these notifications. We'll say v increment v. And we will comment out this closing curly brace and comment out this condition. Now my move function just does all of this. This is a closing curly brace for the frame function. This is new to me. You know, I've seen this before and like tried to understand it. This is the first time I've like used it. So bear with me. I love that. Random direction. We got it to work. Oh, and it does that thing. If I hit it again. Oh. Oh, wait. Okay. Let me try to understand something. If I do every 50 milliseconds. Of course, it'll travel a lot slower. But it's flickering between the two balls at the same speed. Huh. Well, I don't like that flickering. That's probably how is that affecting my there's a task manager in here, perform memory. Oh, not. That's not what I want. Performance. It's taking a while to load. Yeah, so I discovered this recently and was like, this is so awesome. This is so cool. You can zoom in with the mouse wheel and it's laggy. It's laggy. There's so much here. The timer is fired. It took 0.25 milliseconds or 81 microseconds. I don't know. And the function call doesn't tell me which function. But it tells me what was happening on the screen. 2,000 milliseconds, 3,000, all the way to 10,000. So it records as long as you want. And then, yeah, it gives you a screenshot. But it, you can click, you know, on this timeline and go to where you want it to go. And so it has this GPU, like Chrome has a virtual GPU or something. 0.55 milliseconds. 37 microseconds. Composite. Okay, and so you just click and drag. So I'm here at 4,000 milliseconds. So the green stuff on the top is frames. So it has tells me a frames per second. This is the duration of each frame. anyway, this is all just to show you that it's working really hard. It's doing my bidding, or it's trying to. Sometimes it just can't figure it out. And it gets a lot more dense over here toward the end. It doesn't show inputs. It might show processing inputs. Like, well, anyway. So again, I want to, yeah. So it'll check and see if we need to bounce, and it'll bounce horizontally, and then after it's done that, whether or not it bounced or not, the else if will say, oh, if we didn't bounce horizontally, then we'll check this and we'll see if we can bounce, if we need to bounce vertically. So it will only check and bounce vertically if it did not satisfy this condition and bounce horizontally. And I want to do both no matter what. So separate if statements. And then we go ahead and move after we've checked and see if we need to modify our horizontal or vertical velocity. We went ahead and moved. And then we changed the style. Oh, yeah, we move the X, we move the coordinate, and then we apply that coordinate to the styling of that div. And then we increment velocity by 1. Yeah. Well, my back hurts. I think we've learned something valuable today. So I just want to thank you, and I just want to ask you to like and subscribe and, you know, share my videos with somebody that you love or somebody that you don't love, or that you maybe you know you're like cool with them, but you wouldn't, you know. Help me grow my YouTube channel so that I can help you become a better programmer as I help myself to become a better programmer, so that I can work with computers, because I love computers. They are flashy and they have all these different colors. They display all these colors. They just do whatever you want. I say make a ball. Move the ball. Make the ball bounce. And even if I tell it to do something that's totally stupid, it doesn't make any sense, like make these balls and just make them. It's like, I'm trying. It's like when the robot comes to you, yes, a robot, am I beautiful? But don't hurt my feelings. And the robot says, tell me the truth now. You're pretty good looking, I guess. And then the robot dies. You killed the robot by... This is the end. Goodbye.